Hello, welcome to 5.3 and 5.4. We're actually barely touching on 5.3. I would have skipped it altogether, but I think there's a couple things to review about connectives. And then 5.4 is the conditional statements. There's a lot of vocabulary, so bear with me as we go. Okay, something that is new that you've not seen before this class is called truth tables. At least I don't think so. You may have done something similar, but it wasn't with just true and false. So basically it's a summary of truth values for any statement. Okay, so here we go. We have a statement P and then we have not P. So whatever the statement is, which we don't know what the statement P is, we can also negate it. So if the statement is true, then if it's not true, right, the opposite is false. So if the statement is false, the opposite is that it's true. So it's pretty straightforward here. Okay, and we talked about conjunctions and disjunctions in algebra, but we've just never talked about them with statements. So this part is a review, but again, it's in a different context. So you remember as the connector and, we talked about it in set notation as being an intersection. If it's an and, it has to be true for both sets. So that's why I've underlined the word and then I showed you the set notation with the upside down like N looking thing there over to the side in green. Okay, so the notation though when you're talking about statements is like a caret. It still goes in the same direction as set notation, but it's pointy instead of rounded. So if I'm going to say P and Q, it looks like this. So let's look at a truth table with a conjunction. So if I've got P's and Q's, you first have to go ahead and go across. If P, then Q, P and Q are both true, P and Q are both true, then doesn't that mean that they together, oh, I'm sorry, I go down the chart, my bad. Okay, so filling out the chart is a little trivial. If both things are true, if one thing is false, if one thing is false, and then if both are false. So there are 4 different combinations of the and. So if it's true and true, doesn't that mean the whole statement's true? Okay. If it's true and false, you know, that's a half truth, which we know in God's law that means that it is false. If I say one thing's true, but the other part of the thing I said was false, then that means the whole thing's a lie. Okay, and that goes for no matter which part. What if I lie first and then tell the truth? Still false, right? And of course, if I lie to you twice, I'm still lying. Okay, so this is just way of thinking of it. It has to be both pieces of what I'm saying to you have to be true in order for the whole conjunction to be true. And now I have the total opposite. I have a disjunction or an or. In set notation it was the U, but here when I have a disjunction in this kind of notation, it's like a little V. Alright, so see how it still goes in the same direction as set notation, but it's just pointy? That's how I remember. This is the or. Alright, so again, a truth table, I fill out the first 2 columns because I've got true, 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 false, false, true, false, false. Exact same setup, but then I have to think about this now as a disjunction. These 2 separate statements are disconnected. Okay, it's an or. It's either true or true. Well, if it's true or true, the result's true. If it's true or false, can't I pick true to make the whole thing true? See, it's how it's the opposite of a conjunction. Now, if I have a false then or true, again, I can pick true. I can pick truth in this scenario. Okay, but if I have only 2 false things to choose from, then all I have is false left. So a little bit different than a conjunction, because a conjunction, both things have to be true for the whole thing to be true. Here I'm choosing what I want to be true. It's or. Alright, so that was officially the review part. Now we're going to be talking about conditions. I have a conditional statement. It is a statement in the form of P then Q, where if P and Q are statements, then the notation is this arrow. P if P then Q. Okay, so if P represents an if statement, it's a hypothesis, right? So if P and the Q is the conclusion. So if, you know, we're going to do a bunch of examples here, so let me not come up with one on the fly. But if P, then Q. Alright, so let's look at this example. I'm gonna write these statements in an if-then form. And the first one we'll just do together, but I want you to pause part B and see if you can do it on your own. Okay, there are no clouds in the sky, so it is not raining. If there are no clouds in the sky, then it is not raining. Does that make sense? Is that the same sentence as A? Same statement. If, then, form. So if P being there's no clouds in the sky, then Q, it is not raining. See if you can do this one by yourself. Just hit pause and try it. Well, we know this to be true, right? If a blizzard hits, then school will be canceled. But do you see how we had to rearrange the if-then part of B? School will be canceled if. We need the if to be first. So if a blizzard hits. So if P, then Q. Alright, so let's look at a truth table with conditional statements. So again, I still have 4 choices, both true, true, if true, then false, if false, then true, if false, then false. Okay? So it's kind of wherever you end up. That's how I think of it with conditions. So if P, then Q, the then is the condition. So whatever Q is, you're basically just copying it across. If it's true, then true. Okay, it's true then. If true, then false, then the result's false. If false, then true, the result is true. Okay, the only exception is if false, then false. It's true. And the reason for that is, think of it, if I start with false and I end with false, well, that follows law. That follows, you know, even the Lord's law. If something is false and it looks false, well, that is true. So that one, you just kind of maybe think of that as a double negative here. I'm not really sure how you're going to memorize that, but we'll do some examples and hopefully it'll be a little more clear on that last example there. Okay, the next example in your textbook is which is true. If horses had wings, then horses could fly. If ocean water is grade A milk, then ocean water is a nourishing beverage. If whales walk, then 4 + 1 = 5. Okay, so let's look at if horses had wings, then horses could fly. Oh, well, I guess I didn't do this individually, my bad. Okay, all 3 are true because the hypothesis is false. The symbolic forms are if false, then false, because look, if horses had wings, well, they don't. That is false. Then horses could fly. Well, obviously, horses can't fly. So, if false, then false. Ocean water is not milk. That's false. Then ocean water is nourishing beverage. Okay. Ocean water is not a nourishing beverage. That's false. And then if whales could walk, false. Then, oh, that's true. Okay. So, if false, then true. Right? A biconditional statement is if and only if. So this means that a biconditional means that no matter which way I rearrange our statements, then it is true going in both directions. That way that's the reason why we use the double-sided arrow. Okay? So if P, then Q, and if Q, then P. They have to go both directions here. And these are a little bit trickier. But here's a theorem for you. The conditional P then Q, if P then Q, is equivalent to the disjunction or not P or Q. Okay? So like I said, we're going to practice this a lot, and we'll spend a little bit of time on this, so please don't panic that this is a new subject and that it sounds like I'm babbling. I am talking logic, believe it or not. So here we're going to practice, okay? This is total practice. It's not in your text. All right, the first thing we're going to do is fill out our PQ columns. Because we only have 4, that means we have true, true, false, true, false, false, true, false, false. Okay, those are the only options that those two statements could be, right? So, in the combination that they can make. So now, if P then Q. Well, if P then Q for true, true, what do you think it's going to be? Okay, right? We said if the first part's true, then the second part's true, then the whole thing's true. Now, it says not P. Well, P is true, so what's the opposite of true? Okay, so we're going across the top row here. So now let's talk about, if not P, what does the little upside down V mean? It's really important that you know. It's the same as saying union, okay, which is or. So not P or Q. Well, not P is false, and Q is true. But it says or. Okay, so if I get to pick, I always pick true. Now, if P then Q, if and only if, not P or Q. That's what that whole ginormous thing says. So I've already got if P then Q. It says true, right? I have that in my column already, true. If and only if, true. So I've got true, if and only if, true. Already filled out. So if and only if true, if and only if true. Okay, the whole thing's got to be true. So let's do this again for the true false. If P then Q, not P, not P or Q, so false or false. Okay, and now I've got false, if and only if false. Remember, that's my trick one. False, if and only if false, means it's true. Okay, now, false, if false, then true. Not false. Not false or true. Remember, ors. Okay, ors I get to pick. Now we have true, if and only if true. Okay. False, if and only if false is true. Now I've got not false. I've got, let's see, my true or false. Remember, if I have an or, I get to pick. And then I've got my true, if and only if true. Now I've filled out this whole table. Okay, so you'll have things like this we're going to do in class, so I really want you to hopefully understand where this all came from. Our last example is change the following conditional statement to a disjunction. If a child disobeys, then he will be disciplined. So a conditional statement is an if then statement, which is that's what we have, and now we're going to make it a disjunction. So a child obeys or the child will be disciplined. Okay, do you see how I have the or now? Disjunction means or. Okay, we've got some more definitions. A converse of a conditional statement is obtained by switching the hypothesis and the conclusion. So if P then Q becomes if Q then P. The inverse is where you negate both the hypothesis and the conclusion. So instead of if P then Q, you've got not P then not Q. And the contrapositive is where if you have if P then Q, then you switch and negate. So not P, if not P, then not Q. Okay, that's contrapositive is switch and negate. Alright, so now let's practice those definitions. Okay, this is truly our last example. I'm sorry, I forgot that we had more definitions. I told you this was a big one with definitions. So we're going to write the converse, the inverse, and the contrapositive of just this implication. If we have a blizzard, then school will be canceled. So the converse says what? We have if P then Q. The converse is if Q then P. We switch them. If school is canceled, then we had a blizzard. Okay, this isn't necessarily true, is it? We could cancel school because we don't have power. That happened before, but there's other reasons school can be canceled. So see how sometimes switching and making the converse doesn't always make it true, but we at least can write the words. The inverse means I negate both pieces. So if we don't have a blizzard, then school will not be canceled. And last I have the contrapositive, means I switch and negate. So if school is not canceled, then we did not have a blizzard. The last theorem of the day, contrapositive rule. A conditional statement is equivalent to its contrapositive. In other words, if P then Q is exactly equivalent. It's the same as not Q then not P. Okay, so remember, if I flip and negate, I'm saying the same exact thing. So for your whisk summary, you're going to give the converse, inverse, and contrapositive of this statement. If two angles are congruent, then they have the same measure. So go ahead and email me, and I will see you in class.